We will cover the concept of length contraction in this lecture. Let these be two frames. Let S dash move with a velocity v with respect to frame S, and let us take frame S as stationary. Let there be a rod placed in the moving frame with length L0, and let its coordinate be x1, x2, be its coordinate in that reference frame. This we write as dash because in this frame we will write in terms of x dash and t dash. And let the coordinates of this rod, I am drawing it again, be x1 and x2 in the reference frame which is not moving. The length of the rod in the moving reference frame is x2 dash minus x1 dash, and the length of the rod in the stationary frame is x2 minus x1. Now recall the transformation for the relationship for the moving reference frame. The Lorentz transformation, we know x dash is k times x minus vt. Y dash is equal to y because in y direction and z direction there is no movement. Z dash is z, and t dash is written as k t minus vx upon c square. Similarly, we can write x in terms of x dash will be k x dash plus v t dash. Y is y dash, z is z dash, and t is k t dash plus v x dash upon c square. Now out of these relationship, which one we will use when we are working on the length contraction? Which one we will use? Now something which you have to keep in mind is when the observer in frame S is measuring the length, he has to measure these 2 points, he has to look at the same time. He is looking at these two ends at the same time, so delta t is 0. So delta t has to be 0. So in which relationship is the t coming? In this it is in terms of t, so use this relationship. I'm just telling you how to remember which relationship to use. Now use this relationship and we write it as delta x dash is equal to k delta x minus delta t into v. Now this we have taken as 0 because the observer is looking at both the ends at the same point of time, and delta x dash is x2 dash minus x1 dash, which is L0, and delta x is the length which I am measuring or the observer is measuring in the fixed frame. So what the relationship comes now? Place the value, so L0 is equal to KL, and we know that K is under root 1 minus V square upon C square. So length which an observer in the stationary frame will measure will be 1 minus V square upon C square square root times the L0. This is less than 1. This whole term is less than 1, so L will be less than L0. This is what we call as the length contraction. In reality, the length doesn't change. Length is L0. It is only that when the observer is measuring from this frame, to him the length will appear as less. It doesn't mean that rod has changed its length. Its length continues to be L0 in this frame where it is kept, but when I am looking from the stationary frame, I am looking at it as of a smaller length. So this is the length contraction. We can use these relationships for time dilation also, and we'll cover it in the subsequent lectures.